Hello and welcome to machine learning class. What I'm going to do is just spend a little time going over the logistic of machine learning. We will start to talk about machine learning concept and the algorithms provided in this course. My name is Shahab and I will be the instructor of this course. I personally work in machine learning and I have worked on it for about 15 years till now. So the course is interesting and the algorithms provided in this course is more interesting, and I encourage you to take attention of all specific algorithms that we will going to discuss. We can give you some application, real engineering application, medical science application, financial sector, etc., especially management science. So this course is helpful for those students who are interested to take AI for the future. In this slide, some of the resources for this course are presented. There are many resources and references related to machine learning and deep learning, such as Pattern Recognition and Machine Learning by Christopher Bishop. The book is suitable for courses on machine learning, statistics, computer science, signal processing, computer vision, data mining, and bioinformatics. Another course and another books is Introduction to Statistical Learning by Gareth James. An Introduction to Statistical Learning provides an accessible overview of the field of statistical learning and essential tools for making sense of the vast and complex data sets that have emerged in field range from biology to finance to marketing to other engineering applications in the past 20 years. So another interesting book that I'm going to introduce to you is Machine Learning, a Perspective by Kevin Murphy. So a comprehensive introduction to machine learning that use probabilistic models and interface or inference as a unifying approach. So more recently, another book or resource we call Deep Learning by Aaron and Yeshua, an introduction to a broad range of topics in deep learning, which cover mathematical and conceptual background. And also, they talk about deep learning techniques used in industry. This is a very interesting topic. And also, they will talk about the research perspective by using deep learning. In this slide, the prerequisites of this course are mentioned. You must have information about basic algorithm, linear algebra, and be familiar with matrix vector, matrix operation. Also, you must have knowledge related to calculus. So last but not least is programming skill that I emphasize Python, which has so many packages for machine learning algorithm and deep learning structure. You can also use MATLAB and R to implement machine learning algorithm. But in this course, we implement our algorithm with Python language in Jupyter Notebook. It's easy and we will teach you how to install and how to run your program on it. What is machine learning? Machine learning is a subset of artificial intelligence. That is, all machine learning counts as AI, but not all AI counts as a machine learning. Machine learning is an application of AI that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed. Also, you can see deep learning in the subset of machine learning that we will introduce in future. Machine learning, or ML, allows computers to find hidden insights without being explicitly programmed where to look. This is the concept of machine learning and the description of machine learning that I mentioned to you. Here we see some examples and application of machine learning. For example, one of the application is fraud detection using machine learning. In this case, we will deploy a machine learning model and an example data set of credit card transaction to train the model to recognize fraud pattern. The model is self-learning, which enables it to adapt to new, means that unknown fraud pattern. In other words, if you want to detect the fraud in credit card transaction, you can use machine learning. The machine learning model use the self-learning to adapt to the new type of fraud. In the new era of technical advancement, electronic mails, or for example we call emails, have gathered significant user for professional, commercial, and personal communication. In 2019, on average, every person was receiving 130 emails each day, and overall 296 billion emails have been sent in last year. So, because of the high demand and huge user base, there is an shortage and unwanted emails, also known as spam emails. There were times when more than 50% of total emails were spam email. Even in the current date, people lose millions of dollars to fraud every day. Nowadays, systems use ML or machine learning to detect the spam email. This is another example that I will give you. When you look at this picture, artificial intelligence is a main root. In the middle, we have the machine learning, and in the core, we have the deep learning that we will discuss later. As we discuss about fraud detection, the good example is credit card fraud detection. You collect a lot of data set from bank in subject credit card, then you read all the customer data in order to detect what kind of fraud happened. Another nice example is the email spam filtering. And a lot of emails send it to you, and your system should classify which one is spam and which one is not spam. This is another example of machine learning. Facial recognition is a technology that is capable of recognizing a person based on their face. You look at the left picture, we call face recognition. It employs machine learning algorithms which find, capture, store, and analyze facial features in order to match them with images of individuals in a pre-existing database. Another nice example that many people recently look at this example is a stock market prediction. I advise you to choose this topic for your future. A stock price prediction using machine learning helps you discover the future value of company stock such as TSMC and other financial assets traded on an exchange. The entire idea of predicting a stock price is to gain significant profit. They are looking to gain the significant profit. Predict something for you to get the profit at the end, not at the yearly, hourly, or monthly. As I mentioned to you, there are a lot of applications for machine learning. Other applications such as web search result. The people use this spider algorithm. Real-time ads on web page is another type of application that people use machine learning. Credit scoring and next best offer is suitable for financial department, bank, or institute. Prediction of equipment failure. This one is good for big company. New pricing model. Recommendation engine. Many people use recommendation engine, especially those company that they want to help the market to recommend their brand in other social network. Also, another interesting is text sentiment analysis. Many people use the text from Twitter and then they use the machine learning for classification or use the deep learning for predicting what happened to the group of social network by using this word or this text. This is the example of machine learning. In previous slide, we talked about machine learning application. In this slide, we are going to show you how machine learning works. In order to do it, you have to learn what is the machine learning process. The process of machine learning is shown in this slide. First, data acquisition. That means that to collect data from relevant sources before it can be stored. The first step. Clean, pre-processed, and used for future mechanism. For example, if we want a system to detect dog and cat from images, we must collect image from cat and dog first. Data collection. Next step, data cleaning. Refers to identifying and correcting errors in the data set that may negatively impact a predictive model. Data cleaning is used to refer to all kinds of tasks and activities in order to detect and repair error in data. The name is also simple, data cleaning. Before creating model and training it, we split the data into two categories. Training data for building the model and testing data to evaluate the model. It means that before you apply your machine learning, you have to split your data into two parts. One is training data, one is testing data. Let's suppose you have 100% data, 1 million. 70% you can take it or split it for the training, 30% you give them for testing. For training, it means that is known for machine learning. Testing data is unknown for machine learning. You want to just evaluate the model. They understand your testing data or not. So, the last step is deployment. Is the method by which you integrate a machine learning model into an existing production environment to make practical business decisions based on data. This is the deployment. After you learn the machine learning process, you have to be careful about 3 types of machine learning algorithms. There are 3 main types of machine learning. One is supervised learning, another one is unsupervised learning, and the last one is reinforcement learning. We want to focus on these 3 topics. In supervised learning, the label of data are detected, and we created a model based on known feature. It means that in supervised you have the label data. You have output 0, 1. In unsupervised method, we have unlabeled data. This is difficult. And trying to group together in similar group. Many data sets don't have the label. You have to create the label based on the suitable method. In reinforcement learning or RL, that is used in robotic area, and they use one agent. The agent learns to perform an action from experience. For example, the maze program or problem. The maze problem, you put one agent. The agent is looking for the destination. By using and reinforcing the algorithm to do not go to the wrong way, to avoid to go to the wrong way. As we said, in supervised learning, we train a model using label example, such as input where the desired output is known. Be careful, I said known. Through methods like classification, regression, prediction, and gradient boosting, supervised learning uses pattern to predict the value of the label on additional unlabeled data. In other words, supervised learning is commonly used in application where historical data predicts likely future events. Be careful, historical data. For example, spam and not spam in email spam filtering. Historical data, spam, not spam. You can just make label like yes, no, or 0, 1. In unsupervised learning is used against data that has no historical label. The main objective of unsupervised learning is to explore the data and find some structure within, or it can find the main attributes that separate customer segments from each other. The popular techniques in unsupervised learnings include SOM, self-organizing maps, nearest neighbor mapping, K-means clustering, and singular value decomposition. We will talk about this algorithm in future. Unsupervised learning used to segment text topics, recommend items, and identify data outlier. This is very important that you have to mention or take care of this algorithm. Reinforcement learning is a machine learning training method based on rewarding desired behavior and or punishing undesired one that is often used in gaming and robotics. In RL, the algorithm discovered through trial and error which actions yield the greatest reward. Means that the agent is looking for greatest reward to maximize the reward. Three main components in RL are agent, environment, and actions. What is agent? Agent is an entity that can perceive or explore their environment and act upon it. Environment is a situation in which an agent is present or surrounded by. In reinforcement learning, we assume the stochastic environment, which means it is random in nature. And the last component of RL is action. Action are the moves taken by an agent within the environment. We will give you example in future. If you look at this picture, we have three components of RL. One is agent, we have robot, and the robot should act in the environment to receive the rewards. As I mentioned to you, RL is a type of machine learning method where an intelligent agent, we call computer program, interacts with the environment and learn to act within that. For example, suppose there is an AI agent present within a maze environment and his goal is to find the diamond. The agent interacts with the environment by performing some action, and based on those actions, the state of agent gets changed, and it also receives a reward or penalty as a feedback. The agent continues doing these three things. What is these three? Take action, change state or remain in the same state, and get feedback. And by doing this action, he learns and explores the environment. The agent learns that what action lead to a positive feedback or reward, and what action lead to negative feedback or penalty. As a positive reward, the agent gets a positive point, and as a penalty, it gets a negative point. Then we conclude that the agent is looking for positive reward. Then in RL, objective is the agent to choose action that maximize the expected reward over a given amount of time. And the agent will reach the goal much faster by following a good policy. Therefore, the main goal is the agent learn the best policy. The main goal of RL, learn the best policy. Here you can see the roadmap of this course. In the next session, we will talk about Python. After this, in next session, we will start from the beginning of machine learning regression, which includes linear regression, support vector regression, SVR, decision tree regression, random forest regression. Then we will talk about the classification, which has a lot of algorithm on it. We call logistic regression, K nearest neighbor, KNN, support vector machine, naive-based decision tree classification, random forest classification, and neural network. Later on, we will talk about clustering techniques. We have k-mean clustering and hierarchical clustering. And later on, we will focus on dimensionality reduction in order to reduce the size of data set. We use PCA and LDA. And finally, we will talk about deep learning. We talk about CNN, RNN, and some other deep learning techniques, but the main root came from neural network. So you have to keep in mind that machine learning takes time, and you have to work with programming along theory. It's not only the theoretical concept. You have to program in Python. We will teach you how to use the library, machine learning library in Python, especially in Jupyter Notebook. And in next session, we will start using Python for machine learning. Thank you so much for staying here.